Going to section 4.2, we're going to look at equations. This is part one of solving equations. We are going to look at predominantly linear factors here. Pretty straightforward. If you remember solving for x, you subtract over the 1, divide over the 2, x is equal to negative 1 half. So we're going to kind of do the same thing where the trig function sine theta is acting like the x. So two ways they'll ask for you to give your answers, either within an interval notation, one revolution around your unit circle, if you will, or for all solutions, we can go as many times as we want in a counterclockwise or clockwise direction. So let's get started. Same step, subtract over the 1, divide over the 2. Now, sine theta is equal to a negative 1 half, so I'm thinking, okay, that's going to be in quadrant 3 and quadrant 4. So I get my all students take calculus. There's where I need to think about my angles. I need a 30-degree reference angle in quadrant 3 and a 30-degree reference angle here. So 180 plus 30 is going to give me 210. 360 minus 30 over here is going to give me 330. So those are my two answers from 0 to 360. Now for all solutions, now we're going to add to that 360 degrees times n, where n is your revolutions. Either if it's a, say, positive 2, then we're going 2 revolutions in the counterclockwise direction. If n is negative 1, then we go in a clockwise direction. And we'll do the same thing for 330, and we have all of our answers. All right, now you can check this out on a graph. So here's my graph. This is just a reminder for me to get my calculator out here. And we'll make it a little bit bigger. I've already got it graphed here. Hit the trace button, and we can start typing in your answers. We had 210, y equals 0. That's what we want. We're looking for the x-intercept. And then if you want, you can go 210 plus 360 just to make sure that the next one's going to work. Yep, there it is. Our other angle was 330. There's another y-intercept, and again, you can add 330 and 360 to get the next revolution. That's that answer. So we have all solutions taken care of. We are good to go. So I'll bring the calculator back a couple times here. The other type we're going to look at are factoring and the zero product rule. This is really important because there will be trig functions where you have two different trig functions in an equation. So for example, if we were asked to solve, didn't say for x, didn't say for y, you have to solve for both y and x. We would subtract over the y, and then we're going to factor this so we can use our zero product rule, where it says if two quantities are being multiplied together and they're equal to 0, then the first factor is equal to 0, the second factor is equal to 0, then you basically solve for x or for y in this case. So again, I have two different variables, but there's a y in each term, then factor it out. And sometimes you'll just have to force a factor out, which is fine. Take the y, set it equal to 0, that's one of my answers. 4x squared minus 1 equals 0. Now we'll go solve this. We'll add over the 1, divide over the 4, take the square root of both sides, and we get x is equal to a positive negative 1 half. And there's my 3 possible answers that will make this equal 0. So now with trig functions, I have cosine theta times cotangent theta equal to a negative cosine theta. We want to solve this in the interval from 0 to 360. So I have two different trig functions here. This is like the cosines are the x's and its cotangents the y. Move everything over so it's set equal to 0. And then once we have these factors separated, then we'll determine what quadrants we're going to put our angles in to find them. So here you have to factor out the cosine theta. Cosine theta is now going to be set equal to 0, and cotangent theta plus 1 is set equal to 0. So this is already solved, so we can go over to our xy coordinate plane here and think, wait a minute, 0, cosine of 0, that's when I'm at 90 degrees and 270 degrees. 0, comma 1, 0, comma negative 1, the x coordinate is your cosine value. on the unit circle. So there's two angles right there. Cotangent theta plus 1 equals 0. Subtract over the 1. All right, this is going to put us in, well, cotangent is like tangent. We're going to have to go negative, so that's 2 and 4. All right, whenever I get a 1, that's the 45-degree reference angle, so that's 135 here, 315 in quadrant 4. And those are my 4 answers. They're there. Jumped off the screen on me there. Now again, we could bring in our calculator here. May have to shrink this a bit just so I can see my equation. There it is right there. So we can go to y equals. Let me clear that. So we're looking at cosine of x, wrong parentheses, there we go, times, okay, cotangent, we want to put this in as a fraction, alpha y equals. We want to put cosine x on the top. We're just going to use our quotient identity and sine of x on the bottom. Whoops, get back up there. I need to get, that's where I wanted to go. Then we have plus a cosine x. And I'm still in that same previous window, so I'm going to graph it. All kinds of answers here. But again, if we're just looking from 0 to 360 like the direction said, a good option here is to go to your window, change your x min to 0, your x max to 360, and I'm going to change it to 90 degrees so I can see my quadrants. Regraph it. So we had 4 answers. I see 1, 2, 3, 4 crossings. You can hit the trace, type in the 90, y is 0, type in the 270, y is 0, type in the 135, y is 0, type in the 315, y, whoops, I had to hit the enter button, y equals 0. So that justifies your work. Again, calculator is a grading tool. When it comes to the test, I'm giving points for these steps. Just because you go to the calculator and get the answers, you do not acquire those points unless I see those steps. So please keep that in mind. If this happened to be a problem where it was 6 points, and you went to the calculator to get the 4 answers, you only get 1 point. So again, grading purposes only. Okay, next example, we have 2 sine squared theta cosine theta is equal to cosine theta. Again, subtract over the cosine theta, get it set equal to 0. I see 2 different trig functions, so again, I want to be prepared with my all students take calculus where I'm going to be putting my answers. Again, we got to factor out a cosine theta, which leaves us 2 sine squared theta minus 1. Each factor is now set equal to 0. Well, we already saw cosine theta equals 0 from the last one. That was 90 degrees and 270, but now we're putting them in radians. So pi over 2 and 3 pi over 2. Here, we're going to add over the 1, divide over the 2. Take the square root, which gives us plus or minus square root of 2 over 2. If you wanted to see the steps, it would be square root of 1 is 1, square root of 2 on the bottom, rationalize to get to here. Now, plus or minus means you're going to have an angle in every single quadrant. So this, I'm thinking 45 degrees. So a 45-degree reference angle in every quadrant, but it's radian, so we're talking pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And those are all my answers. And again, we can go to our calculator. Y equals, clear that out, 2 sine of x. Now to square it, we just put it on the outside of the argument parentheses. And we subtract it over the cosine. Oops, check. Got to multiply by cosine of theta first. Then we'll minus the cosine. Graph it. Now again, this is still in degrees, but I see 1, 2, 3, 4, 5, 6. 6 answers, and I had 6 answers here. So again, trace 90, that's our pi over 2, that checked. 270 check, that's your 3 pi over 2. All my 45-degree reference angles, 45, check. 135, check. 225, check. 315, check. So all 6 of those answers worked out. All right, example C. 2 cosine squared x minus cosine x equals 1. This looks like it could be a normal quadratic trinomial, so I'm going to subtract over the 1 and think about factoring this. So I'm going to need a 2 cosine x, a 1 and a 1, and the 2 being multiplied over to the 1 has to be a negative. So that one's negative, this one's positive. Set your 2 factors equal to 0. We'll solve these for cosine x. We subtract over the 1, divide by 2. All right, so let's finish this. Cosine's negative, so that means we have to be in quadrants 2 and 3 with a 60-degree reference angle, so that's 120 degrees and 240 degrees. Cosine of x will equal a 1, so that's right here at 0 degrees. Now we're looking at all exact solutions, so we're thinking about adding 360 degrees to this. But if you were to draw these in here, there's my 0 degrees, there's my 120, there's my 240. I'm going from 0, add 120, add 120, add 120, and I'm back to 360, which is 0. So technically what I can say is my answer is 120 degrees times n. That's going to be my answer. Every multiple of 120 degrees, whether it's positive or negative, is going to give me an answer in my calculator. Or, excuse me, for my answer. Again, we could go to the calculator to justify that. Y equals, we want 2. I'm going to be sneaky here, put the cursor on sine and hit cosine, and that's done. And we'll just get rid of that multiplication. And we have to put a minus 1 at the end. Graph it. Trace it. 0. 0 gives me 0. 120. Then you go 120 times 2. There's your 240. 120 times 3. There's your 360, or I'm back to 0. And again, I could do more, but because my screen's only going to 360, it would give me an error message. Okay, example 3. Solve cosine of x times cosine x plus 2. Oh, if this was only equal to 0, we'd already have it factored. You have to distribute into cosine x, and then we have to subtract over the 1. Again, we're looking for all solutions, so we're going to have to add 360n to our answers. Or if we get something like the previous one where they're all multiples of 120, we can shorten up our all solution possibilities. So here, this one looks tough to factor. There's no 2 factors of 1. That subtract to be 2. So I'm going to let y equal cosine x so I can make this look like a normal quadratic trinomial. It doesn't factor, so you can use the quadratic formula or completing the square. I like complete the square when there's a 1 in front of my y squared, my leading term. So I can force this to factor. The negative 1's not factoring, so add that over to the other side and put 2 plus blanks. We're going to find the perfect constant here. To find that perfect constant, take the positive 2, the b term, divide it by 2, which is positive 1, and then square it to get 1. So I don't want to square it here. because these two terms that are squared make up my binomial squared. This squares to a 1. What are the two factors of 1 that add up to be 2? 1 and 1. There you have it. Y plus 1, y plus 1. And now we can solve for y. Take the square root of both sides, plus or minus the square root of 2. Subtract the 1 over, sneak it in front of the plus or minus. Then we'll take our y and change it back to cosine x. So here, this is not going to be our special right triangles. This is all about the calculator. So I'm going to take the inverse cosine of both sides and go to the calculator. So the inverse cosine of -1 plus square root of 2 comes out to be 65.53 degrees. Okay, put the plus 360 n on it. We try this one, inverse cosine here, you get an error message. So this answer does not exist. We're not going to try to force anything. Example 4, solving our trig equations using identities. Okay, so here you have cotangent squared theta minus 4 cosecant theta equals -5. We want to find all exact solutions in radians, so we're thinking about adding our 2 pi n. And now I'm going to go to that cotangent squared theta to my Pythagorean theorem and say, look, there's a cosecant theta here. It would probably be better to isolate the cotangent squared theta by subtracting over the 1 and substituting this in for cotangent squared theta, because now we'll have all cosecant thetas. That's like having a y and an x squared, but you can substitute out x squareds and putting it in terms of y. So I'll bring down my minus 4 cosecant theta equals -5, add over the 5, put this in descending order. What two terms multiply to be 4 and add up to be -4? -2 and -2. Since they're the same, you only have to solve one. Add over the 2. All right, so that's quadrant 1 and quadrant 2, because it's cosecant. So that's inverse. Cosecant is sine. Flip our 2 to 1/2. You have a 30-degree reference angle in quadrant 1 and in quadrant 2, so that's 30 and 150, or pi over 6, 5 pi over 6. Then we go add on the 2 pi n for both our answers. And that'll be our first part of 4.2 video.